In a standard three-way and four-way switching arrangement, two conductors, in addition to a grounding conductor, are required to be run between each switch location for proper operation. This configuration facilitates the traveler connections that are fundamental to the operation of these switching systems. It is not feasible or compliant to switch only one of the load conductors when employing three-way or four-way switching for lighting circuits. Let's break down the principles behind three-way and four-way switching to understand why this is the case. Firstly, a three-way switch setup involves two three-way switches controlling a single light fixture. Each three-way switch has a common terminal and two traveler terminals. The common terminal of one three-way switch is connected to the power source, while the common terminal of the other three-way switch is connected to the light fixture. The two traveler terminals on each switch are connected to each other via two separate conductors called traveler wires. These traveler wires are crucial for allowing the circuit to be completed or interrupted from either switch location. Secondly, the operation of a three-way switch is based on alternating the connection between the common terminal and one of the two traveler terminals. When the switch is in one position, the common terminal is connected to one traveler terminal, completing the circuit to the light fixture. When the switch is flipped, the common terminal is connected to the other traveler terminal, potentially interrupting the circuit depending on the position of the other three-way switch. This alternating connection is what enables the light to be turned on or off from either location. Thirdly, a four-way switch is used in conjunction with two three-way switches to control a light fixture from three or more locations. A four-way switch has four terminals and essentially acts as a double-pole, double-throw switch. It either connects one pair of traveler wires to the other pair, or it crosses them over. The four-way switch is inserted in the circuit between the two three-way switches, with the traveler wires from the three-way switches connected to the terminals of the four-way switch. Fourthly, the function of the four-way switch is to change the state of the traveler wires, allowing the circuit to be completed or interrupted from the additional switch location. When the four-way switch is in one position, it allows the traveler wires to pass straight through, maintaining the existing circuit configuration. When the four-way switch is flipped, it crosses the traveler wires, changing the circuit configuration and potentially turning the light on or off depending on the position of the three-way switches. Fifthly, grounding is essential in electrical circuits for safety purposes. The ground wire provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. In a three-way or four-way switch setup, a ground wire must be included in the cable running between each switch location. This ensures that all metal enclosures and equipment are properly grounded, minimizing the risk of electrical hazards. Sixthly, in the scenario described, where an isolated power panel is used with a 20-amp two-pole breaker and each load conductor is 60 volts to ground, it is still imperative to follow the standard wiring practices for three-way and four-way switching. The isolated power system does not negate the need for two traveler conductors and a ground wire between each switch location. Seventhly, attempting to switch only one of the 60 volts load conductors in this isolated power system would create an incomplete and potentially hazardous circuit. The light fixture would not function correctly, and there would be a risk of unbalanced voltages and circulating currents. Furthermore, such a configuration would likely violate electrical codes and standards. Eighthly, the NEC, or National Electrical Code, provides specific requirements for wiring three-way and four-way switches. Section 404.2 of the NEC addresses switch connections and requires that all switching be done only on the ungrounded conductor. This means that the neutral conductor should not be switched. Ninthly, in the case of an isolated power system where both conductors are ungrounded and have a voltage of 60 volts to ground, the NEC still requires that both conductors be switched simultaneously using a double-pole switch or a switching arrangement that effectively disconnects both conductors when the switch is in the off position. This is to ensure that the circuit is completely de-energized when the switch is off, preventing any potential hazards. Tenthly, when working with fluorescent and incandescent lighting fixtures, it is important to consider the specific wiring requirements of each type of fixture. Fluorescent fixtures typically require a ballast to regulate the current flow to the lamp, while incandescent fixtures do not. The wiring of the 3-way and 4-way switch setup must be compatible with the requirements of the specific lighting fixtures being used. 11thly, if fluorescent fixtures are being used, the ballast must be properly wired into the circuit, and the switching arrangement must not interfere with the operation of the ballast. Similarly, if incandescent fixtures are being used, the switching arrangement must be able to handle the inrush current that occurs when the lamp is first turned on. 12thly, it is crucial to consult the manufacturer's instructions and the NEC when wiring any electrical circuit, including 3-way and 4-way switch setups. These resources provide detailed information on the proper wiring methods, safety precautions, and code requirements that must be followed. 13thly, improper wiring can lead to electrical shock, fire hazards, and equipment damage. It is always best to err on the side of caution and seek the assistance of a qualified electrician if you are unsure about any aspect of electrical wiring. 14thly, in summary, 3-way and 4-way switching requires 2 traveler conductors and a ground wire between each switch location. It is not permissible to switch only one of the load conductors, even in an isolated power system. Following the NEC and consulting with a qualified electrician are essential for ensuring safe and compliant electrical installation. Let's delve further into the intricacies of 3-way and 4-way switching, expanding on the electrical principles involved and addressing common misconceptions. 15thly, the voltage present on each conductor in an isolated power system is measured with respect to ground. In the scenario described, each conductor has a voltage of 60 volts to ground. However, the voltage between the 2 conductors is typically higher, representing the total voltage of the system. 16thly, in a standard 120 volt system, one conductor is grounded, and the other is ungrounded. The grounded conductor is typically referred to as the neutral, and it has a voltage of 0 volts to ground. The ungrounded conductor is typically referred to as the hot, and it has a voltage of 120 volts to ground. 17thly, in an isolated power system, neither conductor is grounded. Instead, both conductors are ungrounded and have a voltage of 60 volts to ground. This configuration is often used in applications where it is desirable to minimize the risk of ground faults, such as in hospitals or industrial facilities. 18thly, ground faults can occur when an ungrounded conductor comes into contact with a grounded surface. In a standard grounded system, a ground fault will cause a large current to flow through the ground wire, tripping the circuit breaker and energizing the circuit. 19thly, in an isolated power system, a single ground fault will not necessarily trip the circuit breaker. This is because there is no direct path for current to flow back to the source through ground. However, a second ground fault on the other conductor will create a complete circuit through ground, causing a large current to flow and tripping the circuit breaker. 20thly, the use of an isolated power system does not eliminate the need for grounding. All metal enclosures and equipment must still be properly grounded to provide a path for fault current to flow in the event of a ground fault. 21stly, the grounding conductor in an isolated power system is typically connected to a grounding electrode system such as a ground rod or a metal water pipe. This grounding electrode system provides a connection to earth, ensuring that the electrical system is at the same potential as the surrounding environment. 22ndly, when wiring 3-way and 4-way switches in an isolated power system, it is important to maintain the isolation of the 2 conductors. This means that the traveler wires must not come into contact with ground. 23rdly, if the traveler wires were to come into contact with ground, it would create a ground fault and potentially trip the circuit breaker. To prevent this, it is important to use insulated conductors and to ensure that all wiring connections are properly made. 24thly, it is also important to use the correct type of cable for the wiring installation. The cable must be rated for the voltage and current of the circuit, and it must be suitable for the environment in which it is being installed. 25thly, for example, if the cable is being installed in a wet location, it must be rated for wet locations. Similarly, if the cable is being installed in a hazardous location, it must be rated for hazardous locations. 26thly, the NEC provides detailed requirements for the selection and installation of electrical cables. It is important to consult the NEC to ensure that the correct type of cable is being used for the specific application. 27thly, in addition to the NEC, there may be local electrical codes and regulations that must be followed. It is important to check with the local authorities to determine what these requirements are. 28thly, when working with electrical wiring, it is always important to take safety precautions. Firstly, always to energize the circuit before working on it. This can be done by turning off the circuit breaker that supplies power to the circuit. Secondly, use insulated tools to avoid electrical shock. Thirdly, wear safety glasses to protect your eyes from flying debris. Fourthly, never work on electrical wiring when you are wet or standing in water. Fifthly, if you are not comfortable working on electrical wiring, seek the assistance of a qualified electrician. Let's also consider the specific types of lighting fixtures mentioned, fluorescent and incandescent. 29thly, fluorescent lighting fixtures require a ballast to regulate the current flow to the lamp. The ballast is an electrical component that provides the necessary voltage and current to start and operate the fluorescent lamp. 30thly, there are two main types of ballasts: magnetic ballasts and electronic ballasts. Magnetic ballasts are older technology and are less efficient than electronic ballasts. Electronic ballasts are more energy efficient and provide better light quality. 31stly, when wiring a fluorescent lighting fixture with a 3-way or 4-way switch, it is important to ensure that the ballast is properly wired into the circuit. This switching arrangement must not interfere with the operation of the ballast. 32ndly, incandescent lighting fixtures do not require a ballast. The incandescent lamp is a simple resistive load that converts electrical energy into light. 33rdly, when wiring an incandescent lighting fixture with a 3-way or 4-way switch, the switching arrangement must be able to handle the inrush current that occurs when the lamp is first turned on. Inrush current is the momentary surge of current that flows when the lamp is first energized. 34thly, incandescent lamps have a relatively high inrush current, which can damage the switch contacts if the switch is not rated for the current. It is important to use a switch that is rated for the inrush current of the incandescent lamp. 35thly, in summary, when wiring 3-way and 4-way switches for lighting circuits, it is essential to follow the NEC and all applicable electrical codes and regulations. The wiring must be done safely and correctly to prevent electrical shock, fire hazards, and equipment damage. 36thly, using 2 traveler conductors plus a ground wire between each switch location is a fundamental requirement for the proper operation of 3-way and 4-way switching systems. 37thly, attempting to switch only one of the load conductors is not permissible and can create unsafe conditions.